Welcome everyone on today's course. And I will, like always, share the screen. Yeah, I will hide this. This is not needed. This is not needed. If you have some questions, please ask. Yeah, because I might not really see your chat. Yeah, and today we'll continue going through MATLAB programming. Hopefully we'll get to go quickly. No, because, okay, it will notify me all the time that, okay, that quality is bad, but nobody complains last week, and it was the same laptop, so I hope that it's still fine. I don't know why, but okay, yeah. So okay, so let's try, yeah. So today we'll go through functions and other stuff, as you can see here, yeah, because almost everybody seems to be proficient in MATLAB, so we'll go through it pretty quickly, yeah. And maybe this is also a good start that we discussed last week, I hope that you remember, also about those quizzes, yeah. So I create few quizzes using this Socrative system, yeah. So we can use them and see how they work. Yeah, they would work, I think, similarly like on this Aki's course in dynamics, in the way that they could add you some extra points to the share. Yeah, so like by following those homeworks and projects, yeah, you would get 100%. Yeah, and with those quizzes, you could score extra 10%. Yeah, so they will add up to your results, so they can just only increase your grade. Yeah, so if you're not willing, you are not losing anything. Yeah. Here is the QR code. Yeah, I hope that you can see it and you can use it. Yeah, and let's see how it works. Yeah, so I hope that everything will be fine. Yeah.
And also copy like visit those of them and the name and copy it into Teams. We would also join like after you.
Okay. Yeah, that's true. Yeah, very good point. Because I suppose that then it will disappear. Yeah, so let's go to the Teams chat. Here is capital letters, here are small letters. I hope that it doesn't matter. I will just type them in capital if it's needed. Yeah, it's easier for me to write my last name than for you. So, okay, perfect. Any questions, suggestions, or whatever else? Or we can just keep going in rapid speed. Or, yeah. So if there is anything unclear, let me know. Yeah. Yeah. But to wrap up the things, next point are functions. Yeah. So the basic building blocks in procedural programming. Yeah. And it's very important to understand them, know how to write them and master them. So we have seen those very simple functions, yeah, like y equal to atan of x, yeah. This is, I think, one of the simplest one. It takes one argument, typically one number, and transforms it into another number. More general approach, it takes zero too many arguments as inputs. Yeah, it can return in MATLAB multiple variables. Yeah, because it's not always the case. Like in C, you can typically return one. Yeah, so then you have to make objects or structures. But yeah, no issues. They can include side effects. Do you know what are side effects? Okay, yeah. So side effects in functions are the stuff that you cannot see on the first side, yeah. So because typically they can take inputs, yeah, and then they return outputs, so like this y equal atan x, yeah. Most likely it doesn't include any side effect, yeah. So it do nothing to the state of the computer. But when functions change in some way state of the computer, yeah, then it's side effect, yeah. So examples can be it changes your input variables, yeah, without you knowing this. Yeah, this can happen, In Matlab, it's not so easy, yeah, but this is side effect. It can print something. It's side effect. It changes the state of the system. Yeah. Or it can use some global variables. Yeah, when it play with global variables, it's side effect. It's called side effect because it's not seen normally. Because what you can see in your code is that y equal to function of x. Yeah, and typically function without side effects, you expect that it will just do what it's written on the screen. Yeah, so it will take your argument and return a function. If you do anything else than that, yeah, it means that you must go to the function implementation or know that something extra has happened, beside this, aside of looking at this line of code. Yeah, that's why it's side effect. Yeah, and to make life easier, it's better to avoid functions with side effect. Of course, you cannot avoid them always because you need functions like to plot, yeah, or to write some information. Yeah, it's clear. Yeah, but the less the better, because then you must be aware of what is happening there, and typically, it requires some extra stuff, some extra considerations. Yeah, because there is one of those rules of programming, KISS. Yeah, keep it simple, stupid. Yeah, which is, I think, very good rule. The simpler, the better. Functions group statements into separate units. I think this is pretty clear. Yeah. Then instead of having multiple comments, you have just one call. Yeah, that do a lot of stuff. And function parameterize a set of statements. This is very hard thing in general because it brings this very pretty powerful abstraction, and we will deal with it quite a bit. Yeah. That instead of having the code that do some specific thing, yeah, we'll talk about this. Then you have just a general function that you can reuse in many places, and there is this reusability. It's important, but also quite, yeah, you have to get used to it. And the key point of using functions is this drive principle. So do not repeat yourself. Yeah. So okay, but this is just about the introduction. Now about functions. Yeah. So here is the simple example from the book. Yeah. It has like two functions. Yeah. I think if you just put this into the script, one key main function ball function called without arguments. And then it called this internal function that it's one of those simple ones that takes one argument and return one number. Yeah. Easy, basic. Any questions? Not really. Just example. Yeah. Function in Matlab looks like that. Yeah. Function typically like below. Yeah. You have a keyword function. Then you have a list of outputs equal name of the function and list of inputs. Yeah. Then you put some comments there, and sometimes it ends with the keyword end. Here is written how the typical declaration, function declaration looks like. Yeah. So again, yeah, when you have multiple arguments, you use those square brackets. Yeah. Then it's always this equal sign, name of the function, and then in typical parentheses, you have the list of arguments. Okay. Declaration, as it's written here, must be the first executable line of the function. Yeah. Is it clear? Because we have two types of files in Matlab. Scripts and functions, they have the same ending M, but they typically look slightly different. Clear? Perfect. In the newer Matlab version, because it's already released from 2016, so it's already so many years that maybe I should skip this note, but they are supported in scripts at the end of the script. Yeah. So we can put them there. Yeah. In the previous version, it wasn't allowed. They always had to be in the separate file. Now they can be in the script files as well. Yeah. And again, script files are the one that doesn't start simply with the function, the definition. They typically ends with end keyword. Yeah. Do you know why it's written here that usually? That because then you can skip all those ends. Maybe it's not the best approach, but you can skip it. Then it can be nested. And you can use return keyword. Anything new or interesting? Perfect. More advanced use, yeah, but here is just the use of the function that used two arguments. At least this it's not nested function because it's this function next to each other. So there is just a file that declare two functions, for example. So this function is not nested, yeah. But simple declaration, pretty simple declaration of the function that takes three inputs and gives two outputs. Nothing fancy, I suppose. Yeah, everything is clear. Yeah, so some variables, some calls, and some prints. And the main function includes side effects because it prints results on the screen. Okay. Let's see how this Socratic works. Yeah, by the way, yeah. So okay, so it works that way. So it's a little, yeah. So here you can see, by the way, the question already. Yeah. Okay. So I now I understand how this works. Yeah. So you can, as I can see now, answer the questions.
Can you answer the
Yeah. Yeah. Sure. Yeah.
does side effect also feels that the function arguments the workplace, like the variables in the workplace, like for instance, changing one of them to like another.
Yeah. But in Matlab, it's not typically possible. We will discuss this. But okay, so the question was if side effects includes when you change the input arguments. Yeah, because in many languages it's possible, but yeah, it's clearly a side effect, especially if it's done. Yeah, because you do not expect your function to play with your input arguments because they are input. Yeah, and then you are changing them to be input-output arguments. Yeah. This QR code. Can I copy this QR code?
Snippet.
Should we put our name or email? Yeah. Uh, I don't know, simply because I have here no practice what is the easiest. Yeah. If you wish, you can just even put, if you're not comfortable with putting your name or email, I believe you could put as well your student's number. Yeah. So, uh, so do as you prefer at the moment. Yeah, both are totally fine. Yeah, especially that your name typically contains your name. I mean, your email contains your name. And it would be really better. Okay, perfect. So should we wait a few seconds until everybody will answer that are
But you make it fine for like time rate. For example, you show the result and then go for the next one.
okay? Yeah, almost full. Yeah, good. To pause responses, I have to upgrade to Pro. So maybe next time. Yeah, but okay. Uh, so yeah, so for sure to make it usable, you need Pro version. But okay, yeah, this is the life. What can you do now of all those subscriptions? Yeah, because you have, I cannot even pause it. So, but okay, yeah. Functions, variable passing and scope. Yeah, variables are passed by value. Are you aware of this? Do you know what does it mean to be passed by a value as respect to be passed by reference? What is the difference?
That's not like the point that I
Yeah, perfect. So because values are passed, okay, so variable are passed by value. It means that when you, in practice, let's say if you change or try to change the input argument in Matlab, except of very small exceptions when you pass a class that is declared that can be changed. But in general, yeah, when you pass a number or matrix or whatever else, yeah, if you will change its value or affect it anyhow, this change won't be seen outside of the function. Yeah, functions have their own scope. So all the variables that are declared in the function are visible only in this function, and then in the possibly in the nested functions. Yeah, except when they, will use the same name to declare variable. Yeah, but I think that in Matlab it's impossible. So yeah, so each function has its own scope, and all the input arguments are treated as local to the context of the function. Okay, so even if you pass some huge matrix and then you change one element there, the change is only visible to the local function. Yeah. So it is said that typically the copy is made. So because of efficiency, it's not typically made, yeah, but it's just monitored, yeah. And if you try to play with it, then the copy is made. But okay, yeah. So it's better not to make changes in huge matrices, yeah, when they are passed, because then it could cost you a lot of memory. Is it written exception are global variables? Do you know what are global variables? Yeah. So global variables, of course, are variables that can have global context. Yeah, because typically you have local context. Yeah. Of course, there are a few contexts because then you have this main context that you use your Matlab. Yeah. It's not global as well. Yeah, because it's just like say main context. Then each function has its own context. And then you can declare function as being with the totally global context, yeah? And each variable that I'll declare like here with the global, yeah, and the name of variable can be available in the whole program. Yeah, it's better to avoid them as much as you can, yeah, simply because, they are pretty expensive to execute, yeah, and they can be source of many issues. And here is a small riddle, yeah, what this code would display. Do you want to solve this riddle? Because this code is pretty nasty. It's quite obfuscated. It has so this code shows a lot of bad programming practices. Short name for variables, so it's hard to tell what it's doing, yeah, and why it's doing. The function names are not meaningful. It uses global in some strange way, yeah, that depends on the order of execution. So it's just a riddle, yeah, and it shows, do not never try not to write this function, this type of the code for yourself or for any practical use. Okay. So, do you want to solve this riddle?
First question is like, is this global is something like private and public variables that we define in other like programming like C#? Like somehow when you define it as a public, like you can access it.
I don't know. Okay, why I don't know? Because it depends, I suppose, where you use this private public, and it really depends on the language. And as far as I know, depending on the language, it can be used in very different contexts. Yeah, but I doubt because in many languages, as I understand, private and public are used to declare the fields in classes. Is it the case in C#?
Like the experience that I had, like when you define it as private, you can only have access in that script, like for example in Unity. But when you
Okay.
define it as public, that we can access it in other scripts as well.
Yeah, local is similar to public.
Yeah, it could be.
So right now we have two global C with different values, like how it's gonna.
No, global is common context. There's one context of
Okay.
global, yeah. So if you put something in global, it's in one global context always. Okay, by the way, I will run Matlab that I don't have, so yeah, so let's see. I will get back here because I have to sign in. Damn, why it's so annoying? That it cannot remember. I will bring this riddle back to you, yeah, but of course we'll yeah. Okay. Maybe we'll just copy paste this to Matlab and see how it works. Yeah, because it will take a while and just a riddle, yeah. So let's save it as, you know, okay. Because at least let's start with maybe with the simple one. What will be value of B here? Yeah. What will be value of C here? Yeah, it's so then it start to be this you know yeah a question what it will be. I can tell you that it will be 7 for sure. I know that you can see that it's global. Global variables are inefficient and make errors difficult to diagnose. Exactly. Yeah. So one of those here that you know it's hard to tell you when you the short code what it's doing. Yeah. Here it sets 12. Yeah, but C this C is not global. It's never declared that it's global. It's in the main context of the MATLAB, but it's not in global context. Global context is separate context. Yeah. So if I were to declare it global, then maybe it could be 12, but it depends on the order of execution of other lines. That's why side effects. Yeah. But it's in the main context. So in the main scope. So in the main scope, C cannot be changed. Yeah. So what is A? It's function 1 with B. B is 1. Function 1 with B. So this is pretty easy, yeah, because we declare here C as being 12, but then we have B equal to B plus 1. So 3 times 2 is 6. Yeah. So what is D? That's the operations, yeah. So D we use with C. C is equal to 7. Okay, so it's not 12, so it's 7. So here E is 7, yeah, because it's parameterization. So it doesn't mean if it ends, doesn't, we could use the same name, other name. But then we have global C, and set it to 1. And then we call this function, and this function takes this number 7. It's make it plus 2, so 7 plus 2 is 9. Twice times 2 is 18. So here is 18 and plus C. How much is C?
12.
Yeah. So it's 30. So then we have 30. 30 plus E is 37. Yeah. So, so let's see if we are right with this. Yeah, we are right. It's 37. Yeah. It's very nasty code. Yeah. Because, for example, if we were here to change the order of those arguments, Despite, you know that typically when you add numbers, it doesn't matter what is the order of the operations, yeah? But here, because of the side effects and use of global variables, it matters. So if we were to change the order, yeah, then we'll add 1 plus 18 and not like here, 18 plus 12. Yeah.
If you now cast the first C as global and you remove the global from two functions, is C continuous global inside the functions, or are the one C is inside the functions now not global?
Not global.
For each function you create, you need to call it global or to be global.
Yeah, because each function creates its own scope. Scopes are always local. So everything that you made in function by default, it's only for this function. Yeah, so have to take extra like steps, like declaring global, to get out of this context.
And it's global. It's like different from public. Because public and like C means it's accessible everywhere without needing to declare it once at the beginning. And then it's like
Yeah, it could be. Yeah, there are always those kind of small. Okay, when you get into those details, small details in programming, that are always the case here. Yeah. Okay. Any questions? Why it work? Why it doesn't work? Okay, perfect. Okay, so we have this, next quiz questions related to what we have done. What is the scope of a variable defined inside a Matlab function? Does it update the question for you in Socrates?
Yeah.
Okay, perfect, perfect. So it works. Yeah.
the question like, what would you then try to define like without needing to like in every single function you could call it global? Any other way to make a variable global to like the entire script you're currently writing?
Every function and everything.
Yeah, basically without needing to define though. There's no basically you need to always say global in essence.
Okay, so basically you should never make global.
Yeah.
Yeah. There are maybe some exceptions, but I'm not aware of them. Yeah. And typically, like in C, is a good habit to, if you have a global name, make it super long, super ugly, and all in capital, that you won't mistake in it. Yeah. So not like global pi, because then you will screw the everyone's code, or it's pretty easy. I think that to get this, but of course, the pattern that you mentioned is pretty useful. Yeah. And so the way to do this is to use nested functions. So then when you have your function, yeah, and then you declare variable in this function, and then you have some nested functions in there, because if you have still a script or function, yeah, then you need those functions, yeah. And then when you have nested functions, they have access to the scope of your parent function. So this is solved that way. Okay, let's wait maybe 20-30 seconds and then let's see about the results.
Continue because we can't pause anyway.
Yeah, I know, but yeah, if I will start talking, you can do one thing at a time. Yeah, so either you can solve the quiz or you can, follow what I'm talking. The issue is that typically you cannot read and follow what I'm talking. Yeah. Yeah, sure. Almost good. Yeah. Functions, handles, and anonymous functions. Any questions to this? Is it clear? With add, you can create handle function or function to the handle. No, handle to the function, sorry. With add, you can create a function handle, or it means handle to the functions. So it means that if you declare that f is something like add name of the function, then it creates variable that is function handle. And this variable can be used as a function. Yeah. Yeah. So like in this next line, when you declare the variable f that became function handle like here, yeah, then when you have f of 4, it's the same like you were to use here the name of the function, actual function. It's very useful to have those handles in functions. Yeah. So then you have functions then operate on the functions, higher order functions. It's pretty useful. Yeah. For example, even in our next example, when you will have numerical integration, yeah, typically you want to integrate some function. Yeah. So how you provide it as a name, so as a function handle in practice. Make sense? Exactly as that's shown here. And of course, inside this function must operate on function handles. Then there are anonymous functions. Do you know what are anonymous functions? Well, they are anonymous, so it means that are functions that do not have names. Yeah, so as you can hear, we have no name here. Yeah, we just declare the function and assign it to variable. They're useful in many contexts. Yeah. Firstly, if you want to pass it to the function that require function handle, for example, and then you can also make some parameterization with them. Yeah. Because here, if we, for example, declare this variable, yeah, and then put them like here into anonymous function, the copy of the value of this variable will be copied here. Yeah, and then it will be the part of the definition of this function. Yeah, so it can be pretty useful. And then use it like here. And here is the definition of the anonymous function. So at parenthesis with the number of the input arguments. So as you can see, this type of anonymous function is limited in the way that firstly, while it can have multiple input arguments, because you can declare here arguments after comma, as always, yeah, it just return one value, and it consists only of one statement.
You make it return a matrix or like that way.
Yeah, for sure, you can return matrix. Yeah. Yeah, this is not a problem to return matrix, yeah, or maybe struct, yeah. So of course you can try to alleviate it, but it's rather done to small tasks, yeah, in Matlab, yeah. So it's rather for those one-liner, yeah, especially when you want to pass some arguments, yeah. Sometimes it's very useful when you, for example, can you use like integration or other stuff. It's very useful when you want to pass parameters to the function that then you want to call in proper order, like here, yeah, that you have some just function, yeah. Maybe, you know, this power is not the best example, but I think that illustrate the purpose, yeah. Then you have some function that is parameterized, and then you can set up the parameter to whatever you want, and then use it in this context in different function. Make sense? Okay, perfect. Function remarks, yeah. So we can have variable number of inputs and outputs. Yeah, if you need, no problem. In Matlab, it's often used from 0 to whatever you can, and you can always figure out how many arguments were passed and how many arguments were required from you. It's a good habit to include function description, yeah, because then you can help another stuff, and then you know what to expect. Functions can be stored in different M files. In practice, if you want to call them in any other scope than script scope, you have to do this. And the functions are recognized by file names. Yeah, fortunately, there's a warning when the file doesn't agree with the file name. Yeah, that, you know, that because then this can cause confusion. Yeah, so watch out when you change the name of the files. Yeah, because this can break your code. M files must be in MATLAB path. Any questions? No. Yeah. Functions calls introduces overhead. Yeah, like always, but you know, we are typically not in the place to worry about this. Questions to functions? Okay, perfect. So we have next quiz. How do you define an anonymous function in MATLAB?
the scripts. For instance, currently when we use Matlab in the scripts, we don't use any header when we just write in them. Want to use them as a function, another thing, we have to like slap them in the first line as like a function.
Okay, so the question was, as I understand, if you about those two types of M file, yeah. So when you have the script file, then you start with whatever, yeah. In the same way, like we can start in this command line, yeah. So you just start with any kind of the expression. So no declaration, but expression, yeah, like assign of variable or printing or whatever, yeah. And then you already start a script, and it will be a script, yeah. So to have a function M file that you can call by its name, the first executable line must be function declaration. So you can have, like many blanks and comments, and it's pretty common that it starts rather with comments, or maybe rather with function declaration, there are comments, but you can have comments, yeah. So all those blank lines, but then it must be function and so and so, and then it's function file. Make sense? Answer the question? Yeah.
Answer. Yes.
Yeah. So like here, because here I have b equal to 1, yeah, then it's just statement, so it's script file. Yeah. And I think that even here, at least in full Matlab, yeah, exactly. You can select here a type, yeah. So, and then if we get a new, for example, script, whatever, yeah, so M files and call it like this SQR, yeah. Then it's script by default because it doesn't start with a function. But when I call it, when I put here function, yeah, yeah, like that. And when I save it, then as you can see, it changes type to function. Yeah, so of course, again, it must be first executable line. Yeah, so if I put here some comment, yeah. Then it's fine, yeah. Oh, by the way, I complained that Matlab editor doesn't have spell checker, but I was mistaken. It has one. Yeah. So I don't remember when I found it. Oh yeah, here at view. Yeah, it has spell checking. So yeah, so it's really nice. So I misspell the word function. Yeah. So I think it's a nice feature. Yeah. And then of course it has a lot of complaints, and it has complaints that I didn't use inputs. Yeah, which is a waste of resources. I didn't assign output, which is not the intended way, and I used the incorrect name. So I can write that c is equal to x plus 2, because why not? Yeah, and then we can check if it works. Yeah. Yeah, so many mistakes in one code. Yeah. And as you can see, it works. Yeah. So it works under the name SQR, and it squares too. So everything is fine. Any questions? Okay, but yeah, let's stop those trolling. So let's fix this part. So let's use correct name, that the name agrees with the script file. Yeah, so then it's not now we'll remove this ambiguity and then make it a proper function. So let's put here the correct one in the way that it works not only for 2 but also for all the other. Yeah. Okay. Wow. Wow. Yeah. Nice. So someone is falling, or someone know how to use the tools. Okay. I have here a hands-on, but I think it's too simple. Yeah. So I will skim over it, and we'll get to something that is more interesting later. And then quickly about the stuff. For loops. Any questions? Understood how they work? Express repetitive task, clear. Example is here, print some stuff, yeah. As I mentioned, I is maybe not the best index, so I use I here. Typically, you use this colon operator to work with the for loops, yeah. It's pretty common, yeah, from 1 to whatever, yeah, from start with step to stop. Clear? However, for defines loop that iterates over each matrix column. Is it clear? Over each matrix column. Yeah, so if you put here for A equal to big square matrix, each A in iteration will be each column. It works because, as you will see, maybe not here, yeah, if you declare 1, 2, 3, it puts 1, 2, and 3 in column. Yeah. So that's why it works. If it were in different direction, you wouldn't get 3 passes. Okay. Yeah, and this is updated automatically after each iteration. Nothing fancy. Yeah. So here is some simple examples. Maximal ball height, native implementation is like that. Yeah, so we have some y values, and then we were wondering what is the maximum in this vector. Yeah, so there is the very simple code like for I equal from 2 to length y. Why not from 1? It could be from 1, but 1 is already used. Yeah, so this very small detail. Yeah. And then we go through all those values. So if it's larger, then assign it, and it works. Yeah, nothing too fancy here. Questions? Double loop. One of the ways, again, naive algorithm to find the largest value in the matrix. Yeah. Yeah, typically you have to pay attention to array indexing, yeah, because they can be tricky, especially if you like mix. There is very easy to make shift by 1 or just mix dimensions from columns to rows and others. But yeah, but here to find the maximum value, because we don't know what is this is another approach. Then instead of using some value from this matrix, we could use A11, but another is to declare it to the smallest number possible, so minus infinity. Yeah, so all the numbers has to be at least not smaller than minus infinity by definition. Yeah, in this step, so we declare that with minus infinity, and then just run double loop with the same approach. Yeah, with first index, with second, and then we just simply check. And if condition is met, we assign it. And then print. Nothing super fancy. Of course, we wouldn't use it in practice. At least I hope that you wouldn't use it. It's the same like using exactly like here, max, yeah, twice. But yeah, any questions? Make sense? Okay, so I have the fourth quiz, yeah. So should I have some, okay, so it doesn't show code. It showed code in some context, but not here, yeah. But yeah, what is the correct syntax for a basic for loop that iterates through the elements of a vector v in Matlab? Assuming it's a column vector. Row vector, sorry. Assuming it's a row vector. Elements of a vector.
Run the code that you just showed the example. Just saying that.
That one?
Yes.
Yeah, of course. And
Yeah.
yeah, any doubt
Like, I just wanted to see that. Just that.
that it works?
Yeah.
Yeah, I also think that, okay, so there are many solutions, yeah, because another solution is just to use that one. I don't even wonder which is faster. Yeah? This should also work. Yeah. And of course, it provides different results because of this round. Yeah, sure. This question seems to be a little difficult. So what is your bet? Hmm?
90.
Oh, you mean 100%.
No. What is your bet about which is correct? And why?
Still not correct because it uses E.
Yeah. It's true. Yeah, I should fix it. Good point. It doesn't mean that it's incorrect, but that's true. It's not maybe the best programming practice for Matlab. That's true. Yeah. It will be better with II. Yeah.
In this case, would it be better to use like the X, Z, Y thing?
Maybe. But it depends on the content. But II somehow it's traditionally used for integers. And typically you loop through integers. Okay, so okay. Why that one and not that one? Simply because it's written elements. Yeah. So if you want to go through elements, you cannot have here because length is just length, and this one will go through not elements, and also it has, it will override V. But it goes through indices. Yeah, not elements. Yeah, so this go through elements. This is just incorrect in MATLAB. It doesn't have this in, yeah, as far as I know. And this goes, it has so many assumptions. If V is a number, then it could work, but again, it's rather some indices. Okay, so this was, I think, the trickiest one from the set I prepared. I hope so. Okay. Another simple for loops, of course. Loops are one of the ways to calculate the sums. Like here we have sum from 1 to n, yeah, to I, yeah. So you can implement it in that way. Yeah, assuming that you want to count it to 5. And typical, and it has typical structure of all the codes that we are written. So initiation phase. So you are defining and initializing the stuff, then you are executing it, and then you are summarizing it by passing it further or displaying here. Yeah, like here. Yeah, and of course, vectorized code that is most likely more efficient, but just-in-time compiler makes it still reasonable. Questions? So here I have some simple hands-on for you. Yeah. And it just brings few stuff. Yeah, you can make it as a function or not, but consider two computational schemes for the number pi. Yeah, one created by Leibniz and one created by Euler. Yeah, so just two different equations. Yeah, and I hope that you understand how they work. Yeah, when k go to infinity, or when index goes to infinity, you will get pi. Yeah, but of course, you cannot go to infinity, yeah, because of many reasons. Yeah, we have some limited time here and memory and whatever. But the assumption is that when you use just finite number of the elements of those series, then you will get some approximation of pi. Fortunately, in MATLAB, we know what is the value of the pi. So write a program that takes n as an input from the user. In one way or another, you can write it as a function or just use this input function that asks the user, yeah, provide me n, yeah, and plots the error development with both schemes as the number of iterations approaches n. Yeah. So the task is to create a plot x, y, when here you have n of x on x-axis, yeah, and on y-axis you have error with respect to that exact pi value error, yeah. So you need some measure for this error. Your program should also print out the final error achieved by both schemes. Oh, okay, this is not super important. Run the program with n equal to 100 and explain briefly what the graphs show. Is this task clear? Is it easy to implement? It's just like maybe 8 lines of code in Matlab. So that why Matlab is nice. Is it challenging enough to bother? Okay. Let's see. Then, so I will give you maybe like 5-7 minutes. So let's say 8 minutes, yeah, to solve this. And then we'll discuss, yeah. We'll see how it goes for you. We'll check the errors. If you online also participate and want to do this, let me know. If you have any questions, just ask, yeah. I have some notifications here. Let's see if there are some. Okay. Yeah, but if you have any questions or whatever, just let me know. And then we can also, like take a look on your code screen or whatever and solve this. If you are willing, then I can spend the next 3 minutes if it would be anyhow useful to solve it, but I think it's easy enough that it's not needed. It's okay. Short break and please try to solve this. Any questions? Let me know. Maybe I will have a question. So is it anyhow for you more convenient when this is, for example, streamed on YouTube? Or it doesn't really matter if it's on YouTube or on Teams?
There's no difference.
I believe later on it would be easier for students to have access to that YouTube.
Yeah, but I told it. And then
Because it will always be there. Like even when you finish your studies, like if you ever.
yeah, but I uploaded. Okay. Yeah, afterward. Because, it stores this MP4 file or something like that on my disk. Yeah, it's easy to find. And like here, I have uploaded to you.
Make any difference?
Okay, that's making it on Teams is just typically easier. Well, especially when camera works not like this. But I think this is somehow the failure of the drivers or something. Yeah. And I really hope to have this my laptop fixed. Yeah. So can we continue with those Teams meetings?
Yeah.
Okay. If no complaints.
I think it's even better with because they can easier to ask you questions in Teams because they can always open their mic, so you can hear something on your computer.
Yeah, that's true. That's true.
When it's on YouTube, it's only the chat.
Yeah, that's true. Yeah, you're right. Yeah, good point.
And in YouTube, you can add images on the chat. So like those top tape.
Yeah. Yeah, but here also you can add images.
But YouTube, you can't.
Oh, you can. Oh, okay.
Yeah.
Oh. So let's go this season with Teams, and then I will put it on YouTube for reference. And sorry to bother. Sorry. Thanks. Any questions?
You know how to do it? So it's also not useful. So I know anyone was able to solve it?
There are some challenges. Okay, do you want me to solve this?
Yeah.
Yep. Okay. Okay. So there are some requests to solve this. Done? Works? Yeah, so okay. So there were some solutions. Okay. That I can solve it. Yeah. So it shouldn't take a while. It always takes a while. It's programming. Yeah. But okay. So okay, so we want to compute this pi by using some series expansions that are proposed by some very famous researchers. Yeah. So of course we have the ground truth of pi. We assume that simply pi from Matlab works. Yeah. So we have to calculate those two sums. Yeah. So I will go the easy approach one after another. Yeah. So here I have because I don't know this by heart. Okay. Yeah. So first one is pi by Okay. And of course, we have to firstly just declare it at 0. Okay, the task also asks us to write that n as input. Yeah. Or simply like what n, yeah, will be good enough. Yeah, so it will ask about n, and then we have to, of course, initialize it to some value, and then write a for loop. And for loop for Leibniz is from 0 to n minus 1. Or k, because k was used there. Yeah. Is it clear why it's from 0 to n minus 1? Okay, good. And then
Maybe because of the
okay, because we want to make a fair comparison, yeah, between both of two. So we want to use just n elements. And because as you can see here, this the one by Euler starts with 1, and the one by Leibniz starts with 0. Yeah, so there is shift by 1. So if we want to have n elements involved, yeah, for Euler we would go from 1 to n. So for Leibniz we have to go from 0 to n plus 1, n minus 1. Yeah, so to have the same number of elements. And because we want to plot it, yeah, we should have here, rather than 0, we should have zeros of 1 to n. Okay, yeah. And there are, like always, several approaches to solve this task. Yeah. So first of all, we need this equation. So 1 over 4 times k plus 1 and over 4 times k plus 3. Okay. There are many issues here. Yeah, so first of all, we can write it as k plus 1. Yeah, for example. Yeah. But this approach works. What is the issue of this code? Correct or not? It's incorrect. Yeah, why?
If you add it all up, basically.
Exactly.
It's plus.
Exactly. So it's not summing it up. So how to solve this problem? There are really, like always, to every programming problems, there are many. We can do it before, after, or inside. Yeah, so I will use the simpler approach. Yeah, because we can use the CMiM function, for example, that would solve this issue for us. Yeah, but we can just solve it by writing, for example, the pi Leibniz from 1 is equal to this is maybe not the most elegant approach, because this approach assumes that yeah, we have to calculate it. So 1 by 1 is not very useful, so we can calculate it, delete it, so it's 1/3 simply, because k is equal to 1. Yeah, and then we are summing from 1 to n in the way that we have plus all that. Yeah. So this is one of the solutions. Yeah, can be done that way. Is it okay? Yeah, so we'll first initialize the first element and then add the following ones. Now it's correct? Let's hope so. And then we do this with the same with Euler. Then we have this equation. So it's it's 8 here. So at the end we have to all this by Euler. Yeah, we can use the same approach. So we can initialize it. For k equal 1 is equal to 1, so it's pretty easy. So the first element will be pi Euler of 1 is equal to 1 simply, and then we can write a sum for k equal to 2 to n. The same principle as above, just shifted by 1. Pi Euler of k equal to pi Euler, not Leibniz, pi Euler of k minus 1 plus, because we have some, I have incorrect keyboard, so it's always changing, and it's simply 1 by k squared. Yeah, and then we have to calculate it by, we have to fix it, because pi Euler in practice, it's all the terms are multiplied by 6, and then we calculate square root of it. Yeah, so we have SQRT and 6 times pi Euler. Okay, so this should calculate those sums. Does it look okay? Everything looks fine? Yeah, so here, of course, you have to care about those indices, yeah, and then depending on the indices, how do you also index your vectors? But then we can plot. We can already plot n versus error, yeah. So how we calculate the error? Okay, but so let's make a plot. So plot will be go from 1 to n, yeah, to have the common basis, yeah. And then we will have firstly pi Leibniz, but having pi Leibniz it's not good because pi Leibniz is simply value of the pi, and you want to error, so we'll subtract pi from it. But then it can be positive or negative, so we'll use ABS function over it. So ABS will provide us one of the error measures, yeah. And then we'll do the same for Euler. And now let's hope that that I haven't made too many errors. Maybe add legend. It even works. It even gives us some hope. It gives us some hope because the error drops to near 0. So there is a chance that implementation is more or less correct. What we can see here, that firstly, the equation by Euler converges faster to the solution, especially on the early stages, but they both get to 0 finally. Okay, any questions? Any doubts? Is it what you expected? Was it easy? Yeah, it takes a few minutes. Yeah, because of some of those stuff that you have to arrange with the loops and others. Yeah, but okay, works. Yeah, maybe it's not super elegant way of importing it. After I would make it maybe more vectorized for this need. Yeah, like we can get rid of those for loops at all. Yeah, but because it's about for loops, yeah, we should keep them. Okay. Something wrong?
Fine.
But okay. I will put, of course, this code as always on Moodle. Yeah. Okay. It's just about debugging a Matlab program. Yeah. So first of all, do you all know how to debug Matlab program? Yeah. So how to debug Matlab program? Put a breakpoint and run. Yeah. So just in case, yeah, later on you will have here, for example, link to Matlab, yeah, with the exact like. Does it work? Yeah. Yeah. Okay. At least it works. Debugging Matlab code. Yeah. So it writes a little, but simply if you want to debug something, yeah, you put a breakpoint by clicking here on the line. Yeah. Of course. Then you run your code. Then code breaks. Yeah. You have here even some helpful functions, and then you can step through your code and check all the variables. Yeah. So you can check like variables, what are values here. You can see what are the values in the workspace. And of course, you can check them here as well, like in debug console. Everything works. Yeah. You can also change their values here if needed, if you want to.
Let's say could be the 1 divided by, there should be another break, like bracket.
They, okay, so now we are here that this is incorrectly written.
Probably show the folder again.
Okay, okay, yeah, I can. Yeah, in programming, you can do the stuff like on many different ways. Yeah. So it also means that if the part of your code is the same like part of the code of the someone else, there is only one, let's say, possibility to this occurrence. Because even when I write the same code, I always write it in slightly different ways. Yeah, because you can use different intonation, different name of variables, different orders, slightly different, algorithm as well. Like here, for example, yeah. Yeah, because I suppose that you were, that instead of putting divide, you can group it and multiply it. Of course. Yeah, but the result is the same. Yeah. And so and so. But okay, but we are here about debugging. Set breakpoints, run file, pause a running file on the breakpoint, find and fix a problem, step through file, and debugging session. Yeah. So are all those steps clear? Yeah, so of course you can step through it, yeah, and then see in live, yeah, how the values are changing. Like for example, how those values are updated, yeah, or how the k gets updated, yeah. We have it too, and so, yeah. And then you can, like check the part of your code here if it works. And then you can check if this change that we described will provide the same result. Okay. Any questions to debugging the code? Nice, perfect. Okay. Oh, I forgot about this question. I have to somehow work out better with this question, but I think it's pretty easy. Is it clear? Sorry about those code here, because when I put this code parts here in the editor of the Socrates, it makes nice formatting, but here now it's lost. Yeah, but for the next time I will know it, so I will avoid it. But here you have the output following code snippet. Yeah, it shows that v is equal to 246. Yeah, and then for one length display v of I and n. I hope it's it's clear. Let's wait a while and let's see if this is anything surprising here. Again, those I have to remember, yeah, to fix it for the next time. And keep using I also in those scripts. Of course, they are, they will work, yeah, and run, but yeah, it's not the best programming practice. Yeah, almost good. Another question. Now it's about debugging. Matlab is paused at the breakpoint, like we have done. How can you inspect the value of a variable? Use the disp variable function. Hover over the mouse over the variable name in the editor. Type the variable name in the command window. All of the above. Hmm?
Was 246.
Yeah. Yeah, because this was the code to show the all values of the vector. Yeah.
So all plus what we
Okay. Sorry. All of the rest. Yeah. Exactly. Yeah. So okay. So yeah. Another good point. And so yeah. So of course this is like test quizzes, yeah. So I will give you points based on your not answers, but based at least for this time, because everything started. So based on your participation. So and because of so we discover a lot of errors here. So I won't even count too much about I won't check the correct answers or not, at least today. Yeah, all of the above. Yeah, because you can also this variable function always in the command line, or just type the variable name in the command line. Because command line is working, and you can even affect the values of the variable in the command line. Okay. Another pretty simple hands-on. This one I won't solve because it takes, but I think that you should try to solve it. The next one will be for your homework. Yeah. And it's pretty easy. I believe so. Yeah. But it also tests how can you create the loops, how you define the functions. So it's a good check if you understand those basic of the programming. So the vertices of the polygon have coordinates, numbered either in a clockwise or counterclockwise fashion. Yeah, so it must be somewhere in the order. Yeah. So like here, you have this figure. So either you have to provide them 1, 2, 3, 4, 5, 5, yeah, or other direction. Yeah, one or the other, so not random, because random won't work. The area A of the polygon is given by this equation. Yeah, so 1/2 absolute value, depending if you count it clockwise or counterclockwise, you can get the same answer but with plus or minus. Yeah, and then you have x1 y2 plus x2 y3 plus to the end, and the end it goes back to x last, y first, minus similar, but you just change the order of the sum, yeah? Y first, x second, and so up to y last, x first. Okay. So for sure, this is a good example for looping. Write a function poly area xy. Okay. So as you can guess, you provide x values for your coordinates in x vector and y values for your coordinates in y vector. It takes two coordinate arrays, yeah, so it will be some row or column vectors depending on your, it should work with both, with the vertices as arguments and returns the area. Test the function on the triangle, quadrilateral, or for example on this pentagon, yeah, because it's quite clear what is area of this pentagon and it's quite easy to get values for here, yeah. Verify results by alternative methods. Yeah, with triangle it's pretty simple. Yeah? So we figure out the coordinates of some triangle that is, for example, whatever your like triangle of some rectangle, yeah, square, it should always work. And with this pentagon is also this pentagon is made in a way that it's easy to calculate the area. So what about spending like 7-8 minutes and try to solve this by writing this function? And you have questions, let me know. Yeah, but you know, I would prefer to hear it because then I have to change the screen. So can you ask the question?
Possible to work with Matlab.
Well, okay, so is it possible to work with Matlab online? I think so because I use Matlab online. Yeah, so I have no issues with logging using my university credentials. Maybe if you have seen, even I have done it at the start. And after I just search for Matlab online, yeah, and just logging with my university credential, it worked, yeah. If it worked for students, I don't know because I'm not student, but do you know if it works?
It should.
I think it worked last time.
Yeah, okay, yeah. So I really advise you to test if it works. And it seems to work pretty fine, this Matlab online interface, like for me.
So I will do this stuff back.
Yep.
take a break, so it's fine.
Yes. You can the thing we
Probably break the point anyway.
Yeah, most of them do this online. Some and other. You can always program custom solve that. Still. Changing. Changing.
Yeah, I'm trying to follow this. I have friends.
No, to like step to the array, move it by one, yeah. I don't remember what is the function, but there is, I think there is one function as well as that shifts does the element.
Yeah, I don't remember.
So do you think it would be how useful for you if I would solve it? Or we can just go further?
it's always good to have that solution for the example.
I don't know, man. Do you think, can we ask ChatGPT to solve this?
That's sure. Why not? Let's see how it works.
Depends if you have the upgraded version, like the old one is still stupid.
Yeah, I have. Yeah. Okay, but it, by default, it provides it in Python. Yeah. So, so oh, I have to, okay, let's wait until it ends and I will fix it to provide it in Matlab. Yeah, yeah, great. Yeah. Oh, and it gives some extra stuff for the report. So this is very nice. Yeah, but can you rewrite this to Matlab code. Okay, sorry. So it provides function that returns polyarea xy, and length of x, number of vertices, yeah, a initialize if there are some terms based on the formula. Add the last term involving the first vertices. True, yeah, because it must be added separately. Take the absolute value and divide by 2, yeah. And example for the triangle, quadrilateral, and pentagon. Okay, yeah. So I wouldn't write it in so nice way, of course, yeah. So let's see if it works, yeah. So the issue is that it's not really provided in the way that we can use it as a script, yeah, because it goes function first, so it wouldn't run. So we have to at least make this change to paste the function at the end so that it runs as a script. Yeah, it provides results, and at least the implementation also looks pretty correct. It's quite concise. It doesn't use any this kind of, how to tell it, yeah, any strange features, yeah. So it's just based on very basic programming, like create, initialize the values, then make simple summation. Then of course you have to take care about the outliers, yeah. And I mean, this is the reason why it goes from 1 to n+1, yeah. It goes from 1 to n+1, of course, because here we start with first element and the second element, yeah. So we have to care about this. And when we go with the indices, it works pretty well, exactly like here, like I-1 and I, yeah, until the last element. That works differently, and it takes care about this. Xi, yi plus 1, xi, yi plus 1, minus yi, xi plus 1, minus yi, xi plus 1, exactly as is written in the code, from 1 to n minus 1. So it will go to n minus 1 and n, exactly, n minus 1 and n. And then at the last line, it takes care about n and xn and y1, and of course yn and x1. It sums up everything nicely, and then at the end, it makes this absolute value and then divided by 2. It looks perfectly fine for us. And it takes it from the slide. So that's why I'm a little worried about our assignment this year, but let's see. Yeah. So if you use in the assignments large language model, just write that you use large language model, then tell how exactly you have to use. Yeah. So what are the prompts? What are the outputs? How you have modified the outputs to get the results, and then write report. It could happen. Yeah. What can we do? Yeah. You also have to learn how to use. Okay, any questions? Works? Yeah. Okay, and this is the homework. Let's see if you were able to solve it as well, or if you are able to solve it. Yeah. So, I will leave it for you. Yeah. Here, and of course on the web page. But this is really part of the homework. So write the function xy of random worker that starts at x0, y0. So this is origin of your work. N is the number of the steps, and D is the length of your step. Use this function to generate path and create plot. Yeah. So here is the example. Yeah, so we start somewhere. Yeah, like here, for example, 0, 0, but you can start in every point you want. Yeah, and then you take random steps. Yeah, in any of those directions. Yeah, like north, east, south, and west. Yeah, depending on random number generator. This function to generate path and create plot. Yeah, and could you vectorize code below using array, bool operations and count sum? Yeah. This is pretty challenging, so especially this last part is good to do with maybe some LLM and then see if you understand the results. Okay, but this is for the homework, home assignment. Questions? While loops. Do you know about while loops? How they work? Yeah.
Infinite loops really easy.
Yeah, of course. While this one. Yeah. So yeah, that's true. It's very easy. They can be pretty tricky. Of course, they work. And they work in a way that until the condition here is true, the code will run. Yeah, so that's why, it's very easy to make infinite loop. Yeah. And here it works in a way that if you have y that at some point will be below 0, yeah, this will give you the point when it changes sign. Yeah, assuming that we start, or it doesn't really matter now. If we start above 0 or below 0. And of course, if it never changes, then it will run to errors. Yeah. A loop body is executed until condition is true. Okay. Anything to add? Not really. Okay. This hands-on was much simpler than the previous one. So if you run into infinite loop and you want to stop the program, hit Ctrl+C. At least it works with the desktop version. I'm not sure about this online version, but in online, I'm pretty sure that when we are running here, we have this stop button that we also, I think, can stop execution. So Shift F5, yeah, but Ctrl+C works. There are two extra commands used with loops, yeah, break and continue. Known, break breaks the most inner loop, continue skips one index or one execution and goes to the next one. Okay. I believe that here I have another question for you. Yeah. What will happen with the following code? Count equal to 1, while count smaller than 5, display count end. This loop will run 5 times and display number 1 to 5. This loop will run indefinitely. The loop will run once and stop. Matlab will throw an error.
B is quite similar.
B and C.
Because of B will have one. Because of B will happen.
Because of B, D will happen. You think so? I have to get rid of this code stuff, yeah. So of course,
Even if it's not this Windows will describe them. So.
yeah, maybe, but stopping and throwing error, yeah. But who knows? Maybe everything is changing, yeah. So
Also like remember in Java or like C++, at least that it starts and at some point like too many loops it says.
yeah, but it's not the error. Maybe it's not throwing the error in the standard way, yeah. But of course, yeah, there is some ambiguity here. So yeah, so I hope that it will run indefinitely, yeah. So not once, because there is no way, because count is not updating inside the loop. So as you can see by this, at least I can see on my resolution that there are some small motions here that suggest that this is still running. Yeah, because there's and
Can you go try the control C? It seems like it, yeah.
yeah, it also works here. Yeah. Nice. Operation terminated by user. Okay, so for sure it doesn't throw an error. Okay, here are just a few words about reading and writing to files. So we can read Excel files, some delimited files, table, write tables, and some other stuff. Yeah. Okay, and good idea is to start with import data tool from Matlab home ribbon. Yeah. So if you have some text file, yeah, and when you have home ribbon, yeah, or other file with data, it's good to start maybe from import if you don't really know what is the type of it, because then it can provide you with some clues and typically allow you to format the file. Yeah, so it's pretty easy and convenient way. Yeah, so if one of the standard ways to read the file, like just load the file, yeah, it doesn't work, it's good to check that one. So like if you have this very simple file, yeah, with just something like comment and the numbers here, yeah, then either you can do this with super hard way, like in very, very old days, yeah. So yeah, in I think early version of CMiM, you have to go through it, like open the file, check it, check how long it is, declare variables, so yeah. Or in the modern times, fortunately, you can just load file just like with that one comment, and it will try its best to do the stuff. Yeah. So the first version, of course, works, but it's not very practical. Yeah. And then you can just save it using this ASCII command to generate text files instead of having mat file, because if you use stuff like that, it will just give you a mat file. Okay, and depending on what you need. Okay, works. Okay, so this is another task for homework. Yeah, sort array of numbers. So create a text file with 10 mostly different numbers. Read the numbers into Matlab. Write a function to sort the array so that numbers appears in increased order. Use insertion sort. Let the program make a print of the array to the file, both before and after sorting. Confirm that array has been sorted correctly. Insertion sort, one of the simplest sorting algorithms. Efficient for small data sets, yeah, because maybe you have heard about bubble sort. Have you ever heard about bubble sort? So it exists, but it's not even efficient for small, yeah. So while insertion sort can be used in practice, yeah, because the bubble sort is pretty simple, especially about how it works, but it's super inefficient. And you can just go to Wikipedia to see how it works nicely. And also there is pseudocode, yeah. So if you use LLM, you will see if it works for you. If not, if you go to Wikipedia, for example, first of all, it's here nicely shows how it works, yeah. And of course, then it nicely describes the algorithm. Here it's even nicer how it works, yeah. So it selects the next number and check where to fit it here. Yeah, if it's fit here, no, but it fits here, so put it here, yeah. So it goes like that. So number by number, yeah. So it doesn't traverse all those matrices all the time, yeah, like bubble sort would do, yeah. Would do those comparisons, yeah. But it just checks one number and compare it with all the stuff and put it in correct order. Yeah. So I think it's quite intuitive how it works, yeah. Take the next one, check, fits here, no, fits here, no, fits here, no, fits here, no, fits here, yeah. So it put it here, yeah. Pretty simple, yeah. And again, with those numerical analysis, it shows that for small matrices, it's still efficient. So maybe better than even quicksort, because again, there are many sorting algorithms, they have their uses. Yeah, it put it here, works. So how to code it? You can do that in many ways, but here we have pseudocode for it. Yeah. So I think it's pretty straightforward. Yeah, of course we have to I equal to 1, even like in Matlab, yeah. I smaller the length, j larger to 0. I think that it looks like it's no, I think it's for pseudocode. Oh, where the arrays are 0 based. So we have to shift the code by 1. Because in Matlab they are 1 base, yeah. So you just have to shift those indices just by 1, plus 1 to all of them, and then it should work. And of course, then you have to adjust also those conditions. Because if they are made for 0, here you have to put equal sign, for example. Yeah. So we have to shift all this by 1 and then implement swap function, but swap is pretty easy. You just swap the numbers. Maybe there is even a function swap in Matlab, I don't remember, but it's easy to check. Or there are also maybe some other functions that already make a swap. And swap is even written here, so really nothing crazy. And this is with expanded swap. Yeah. So this is almost ready to implement just by moving it by 1. Okay, and so this is assignment. Yeah. So just solve those two hands-ons on random walker and sorting. Write a brief report. And you will be graded mostly based on report, and submit the report with source files in zip. And please give me M files. I don't want anything else than text files, M files, okay? Just 2 or 3 M files, depending on the task or whatever number of M files you are considering. Zip file, not RAR file. Yeah, or anything else. Yeah, zip is, I think, supported everywhere in every system, and it works just great. Yeah, and PDF, not Word file or anything else. Okay. Yeah, and now it's a question if this deadline is good because it's in 2 weeks, or maybe 1 week will be enough for you. Because if we will go fast enough, maybe. Okay. Is Matlab Live MXX? Okay, no, it's not text file. Please give me M file. M file is M file. Okay, I think it's not a big deal. We can always do it in this MLX, then copy paste and put it in M file. But for me, it's much easier to check M files because then are just text files. I can just take a look on them quickly, and sometimes I don't even have to run them. Okay, any questions? And again, if you use LLM, it's okay, but you have to write it that you use, which LLM, what queries you have used, what answers you get, and how it provide, and then how do you check that the code runs correct? Yeah, if you haven't written it. Okay. Okay. Questions?
Do we send you the files on email?
Model.
Model.
Model. Yeah, I will create. Yeah. Good question. Yeah. Okay. Thanks. So I will create this assignment on Moodle, and I will grade it on Moodle, and yeah. So please, send it there. Those 2 files. Anything else? Not really. That's perfect. Okay. So we still have like 20 minutes.
It seems good.
Yeah. So we can go through diagrams. Yeah. So this is the first numerical method that we'll use, yeah, computing integrals. Yeah, you know what is integral from math. And maybe have you ever had this kind of numerical method? Teach?
Applied mathematics. There is a code.
Yeah, so you know the topic. So what method?
Solving integral using numerical.
Yeah, yeah.
And you
Okay. So we'll also go can go pretty quickly through it. Uh, yeah, but okay. Yeah. Good point. Yeah. So this is typically one of the very first approaches for numerical methods to show how they works. It's relevant. It has very good graphical representation. It's clear how it works and why it works. It's important because you cannot solve most integrals analytically. And sometimes even if you can, you prefer to do it numerically because of the convenience. Then we can also discuss about exact mathematics and numerical mathematics because we won't get ever exact value. Yeah, well, maybe with some rare exceptions, but typically you don't get exact values. And for integration, we don't have to care too much about those rounding errors because they typically have tendency in the integration to cancel out. Yeah, and how to write the code for it. So, okay, integration. Of course, we are talking about this definite integral from a to b, for example, of f of x dx, yeah? So by definition, if you know antiderivative f of x, you can calculate it easily, yeah? But there is a question how to get it. And again, in general, it can be challenging or whatever. Numerical methods provide approximation only, but solution is straightforward. Yeah. Is it clear why it provides approximation only? Well, this is characteristic of typical numerical methods, yeah. That that you find you have to whatever task you have, yeah, like here, some function, you have to somehow simplify it, yeah. And then you have convergence criteria and other stuff, yeah. You'll see where the error came from. And for numerical integrals, it's very easy to spot where the errors came from, yeah. Should we care that solution might not be exact? It depends. So we should care or not, yeah. And the answer is not straightforward for this kind of the question, yeah, because you have to calculate the integral, yeah. For example, if you want to calculate it, you have to take care about stuff, if this is the thing that you want to get, yeah. So if you want to be very exact, you have to check the convergence, for example, if it's close enough, yeah, if the algorithm is correct and so. Typically, if the error is small, you don't care. But maybe in your application, you really need very rough estimation. So it's not so easy to answer. For sure, it's good to be aware of this, that it's not exact, and how to check if it's good enough for your cases. Yeah, because this then is applied to all the other stuff that are like this finite element analysis is one thing that you typically make some convergence analysis to ensure that your strain stresses or displacement or whatever you get, your solution is pretty good enough or not. But yeah. Some measure for it is needed. Okay. Okay, basic idea. So so we have this kind of integral ab f of x dx, clear, yeah. So in most methods you split this interval into smaller ones, yeah. So I think this is clear, yeah. So instead of having it from a to b, you split it in many more smaller pieces. Usually points are evenly distributed for simplicity and also of practical importance, for example, when you have some measurements. And under this assumption, the integration points are like that: xi equal to I plus I times h, when h is your step, and step is by b minus a times n, when n is the number of intervals. Clear? And then, because of the nice properties of the integral, that you can sum them up, yeah, you know that integral over a to b of this function is equal to the sum of the integrals over all those smaller intervals. I think, yeah, this should be pretty clear, yeah, because a0 is a, xn is b, and we just, keep it that way. So, any doubts? Clear? Yeah. So we end up with a number of small intervals. Over small interval, f can be approximated with simple function. So this is the place where approximation came into play. Yeah. So we assume that as we make those intervals smaller, all those function parts will look more or less the same. The same goes with this derivative, yeah. Then when it's small enough, it's like line, yeah. And we use the values like constant value, linear or parabola, depending on the method, yeah. So the different methods use different approximation techniques, have different convergence, different errors, and so on. But the rule is more or less always the same, yeah. And and with varying interval length and approximation function, we can adjust accuracy. Yeah. So if we use extremely small intervals, then accuracy is typically better than the large ones. All this makes sense. Perfect. I have here a computational example, but I think that I also have some. Yeah, I have to. Do I have some quiz here? Yeah. What is the first step in developing a numerical integration algorithm for the function f of x over the interval ab? Divide the interval into smaller subintervals, compute the derivative of the function, apply the trapezoidal rule directly. We'll talk about trapezoidal rule soon, yeah, but use a fixed step size for approximation. Yeah, I don't know. The 6% and 94%, seems to appear here very often, this division. I don't, but okay, yeah. Use a fixed step size for approximation is a characteristic, not a step. Okay, computational example. Yeah? So for this developments, as always, we need some basis, yeah, for comparison. And here we'll just use some example that it's not super trivial. Yeah. So for example, like constant function or linear function could be too trivial, yeah, to deal with, yeah, because it's very easy. So here is some function like that. Yeah. So with some exponent and some powers. Yeah. So, but maybe it looks pretty similar. Yeah, because it has clear antiderivative, pretty easy to calculate it. So again, we talk that typically we don't have antiderivative. This is the case, but when you implement the method, we want to have some solutions that we know the exact answer, if possible. Yeah? So that's why we choose some function that is not super trivial, but still that we can have some solution like here. So we have the basis for comparison reason 1.718. And in programming language, of course, many more. Yeah, but we have exact antiderivative, so we can calculate it pretty nicely. Make sense? Yeah, we can complain that we have some number 0, 1 here because they are too nice for checking, but we can live with. Then we can check on some methods. So anything about this? No, we can even make it some, can even make it some physical system that, for example, this is our velocity, and then we try to figure out what is the distance of the car that drives according to this velocity. Yeah, and then we have even some units, meter per second in meters. But okay. So here it shows how it goes. Yeah. So on the left, we have our function. So with those, let's say that then this is velocity. So the area below, so this yellow area is our path. Yeah. So the length that we travel in time to 1 second. So firstly, we divide our interval, the whole interval from 0 to 1 into smaller sub-intervals. Here, for this, to magnify it, it's divided only into 4 smaller intervals. Yeah. So with all 25, so 1, 2, 3, 4. And here is a composite trapezoidal rule. Yeah. So trapezoidal rule makes trapezoids out of it. So in this rule, we simplify the function by straight line. Yeah. So here we can see this below is original function, but we simplify it in straight lines. Yeah. And of course, then we sum it. Yeah. So it's approximation because again, we simplify the function. Yeah. So we're not using the original one. As you can see, here it's clearly the source of the error. Yeah, because there is some area between the line, this black line, straight line, and this curved line. Yeah, and this area will be calculated as part of it. Why it's clearly mistake. So here you can see quite nicely where this approximation errors came into play. Yeah. But as you can guess, yeah, if we will increase the number of those intervals, clearly the error will reduce. Yeah. Because, for example, if here we introduce extra point, extra interval, we'll got those 2 straight lines. Yeah. And big chunk of this area will disappear. Will not be included. Still, there will be errors, but there will be smaller one. Yeah. And if we make this division by maybe 1,000 points, yeah, then it's really nicely and accurate. We'll test all that stuff. Make sense? No questions? Perfect. So here's the solution using composite trapezoidal rule. Yeah, while it's composite because trapezoidal rule is to approximate interval by trapezoid, and composite just composite of multiple trapezoids, and this is the reason for the name. So here it shows the solution for just those 4 trapezoids. Yeah, so simply, yeah, we take value of the function at start of the trapezoid, end of the trapezoid, divided by 2 and multiply by h. Yeah, so clearly we can see here, yeah, that we get value here. So this is one side of the trapezoid, another side of the trapezoid. Yeah, yeah, we add those two, divide by, we add those values and divide by 2. Pretty typical for trapezoid. And then multiplies by the height of the trapezoid. And then we sum all those parts and we get to some solution. Yeah. And even with just 4 trapezoids, we can see that we get the error of about 12%. Not super happy, So we use more trapezoids. Why we can use like 4 trapezoids and calculate it by hand? Who will do this? Yeah, but you still can. Yeah, when you use 1,000. Okay, it's clear why we want to use computers. Yeah, we want to use whatever number of trapezoids we want and use computers. So here is general algorithms for it. Yeah, I hope it's clear. Yeah, so this first line is the line that we have already seen. So it's the line when we split the interval over the integral over AB interval into smaller subintervals. Clear, yeah? Next is the step when approximation happens. That's why we have here this approximation sign. So here approximation happens, yeah? So we are changing the actual function to those straight lines, yeah? And as we are changing those straight lines, we are approximating all those small integrals over small intervals. Okay, small integrals. Oh, those integrals over much smaller intervals as trapezoids. And now we have seen this in the last slide. Yeah, here just it's done in the way that instead of 4, we have n intervals. So n trapezoids are summed up. Yeah. And the next 2 lines are just to group the expressions to make it in a way that it's reasonably easy to implement. Okay. So here is just, we are just moving common factor h half, outside of the parentheses. Yeah. And then group them together. So we have the first element, 2 times all the other elements and the last element. Clear? I think no rocket science here. Yeah. And then to make it even, just easier and direct for implementation, we are rewriting it in the way of the summation. Yeah. So of course, all the middle elements looks the same. Yeah. So we put them into the sum from I equal to 1 to I equal to n minus 1 times fx. Yeah. And of course, 2 of those parts that are at the end of the interval, we just add them here with 1/2. Any questions? I think it's pretty straightforward, all those processes, yeah, how to develop this algorithm, yeah. So we have developed the algorithm, name, composite trapezoidal rule, yeah. So after developing the algorithm, what is the next step? Yeah, exactly, implement it. Yeah, so now we would like to implement it. Okay, so here is the short discussion how to implement it, yeah. So do you know this trade-off about specific implementation and general implementation, and what is the difference and what is the characteristic? Is it clear? Specific, it means that it applies to specific problem. So for example, like we define this problem with v equal to whatever was this function, yeah? So you can write a code that just use this function and implement it into the algorithm, yeah? Or general approach, you write a function called trapezoid that gets any function and all the needed parameters like the intervals ends and n, yeah, and then code it in the way, yeah. And well, in engineering world is pretty typical and pretty common to use this specific approach. It's typically much faster, easier to understand, much easier to understand than general one. But yeah, here is written, are the trade-offs, yeah. So if you do specific way, yeah, and then so you blend together your problem with the algorithm, it works of course only to this problem. And if you want to apply it to other problem, you have to make many changes. Source of errors, other stuff, yeah. So if you have, so typically it's better to generalize it. So write just algorithm separately. So then just create like here function trapezoid of f, so function handle A/B intervals and n, and then solve your problem with it. Then you can test it, can verify it. It's much easier to use with other tools, but typically it's much harder to write. So it's really an exercise from abstraction level, yeah. And from here, from this mechanical, yeah, like we, for example, ask often the students to solve using, for example, even the Lagrange equations, yeah, some task like 4-bar mechanism or something, yeah. It's pretty easy to solve it that way because then you have this mechanism that you write your Lagrange equations of motion in any form you want, yeah, and then you have just one equation of motion that works for this mechanism. That's perfect, yeah. But then if you have another mechanism, you add a link, change some parameters, whatever, you have to repeat this process again. Of course, the alternative is to write the program that solves any mechanism and then solve one of those, but the leap between all those two approaches is a big one, and we will take it later. Okay, but we run out of time for today. And we will start the next time with this general implementation of the trapezoidal rule. Yeah, and I believe that after implementing those like other methods, this one should be pretty straightforward. Yeah. So write the function, return the approximation of the integral. It's clear. Test your implementation on this function with this antiderivative to see if it seems to work correctly. Okay, but that's all. We won't go further. Also, we won't do any implementation today, but we cover a nice chunk of the method. Any question, suggestions, doubts, comments, suggestions for improvements? Okay. Anything from online?
Few questions.
Is there a function in Matlab that which can do integral approximation? Of course, I suppose there are many of them. Yeah, but yeah, they are. It's super easy to find. And even one of those was maybe shown here. Yeah, but I think that there is even a function that it's called simply integral. Hi teacher, when will the homework begin? No task appear on the Moodle page after last week's lecture. Yeah. Besides, can we students access to the correct answers of Socrates in class quizzes? I haven't thought about this. Did the quizzes affect average grade of the course? I don't understand this question. So if you have this question, you have to ask them more direct.
Class or does average grade basically mean integrated in the normal grade? Similar to the exercises.
Where do we put the homework? Are there some extra credits awarded from the Socrates quizzes? So I should make it Socrates quizzes out of this maybe, but yeah, there is. If this is the question, so yeah, there is. And so, so does it affect average grade of the course? So in this regard, yeah, it affects. Yeah, but it's done in the way that by taking part in those quizzes, yeah, if this will be successful, but it seems to work reasonably fine, yeah, then you can just get some extra points. So it goes into this direction, yeah, that you cannot lose any points. So even without taking part in any of those Socratic stuff, you can get the full grade. I hope this answered the question. Okay. If there is no other questions, so then thanks. Thank you and see you next week.
Thank you.
Okay.